Friends, when we say we want to design a shaft for an application, then what does we mean to say? The answer to this question is that we want to determine the diameter of the shaft. That is, we have to find out the diameter of the shaft. That is the main motto of designing of a shaft. So in this shaft designing, our main objective is to find the diameter of the shaft. Now generally, the shaft is subjected to many types of loads simultaneously. For example, you can see that this shaft in figure is subjected to bending movement denoted by MB and twisting movement denoted by TE as shown here. Now to design the shaft, we follow two criteria. On the basis of these two criteria, we can find out the diameter of the shaft. Now the first criteria is design on the strength basis. That is, on the basis of the strength, we have to find out the diameter of the shaft. Now according to this criteria, the following condition must be satisfied. And what is this that condition is? So the condition is the stress at any point in the shaft due to the given loading, okay, must be smaller than the permissible value of stress or limiting value of the stress. That is, because of the loading as shown, you can see in this figure, this is the loading condition in which the bending movement and the twisting movement is acting on the shaft simultaneously. So because of this loading, some stress will induced in this component, and the maximum value of stress induced in this component because of this loading must be smaller than the permissible value of the stress or the limiting value of the stress for the material of the shaft, the material of which the shaft is made of. So this is the condition. So when this condition is satisfied, that is the stress induced due to the given loading condition in the shaft, which is smaller than the permissible value of the stress or limiting value of the stress for the shaft material, then we say that the shaft is designed according to the on the basis of strength criteria. Now the second one is design on the basis of rigidity criteria, that we will discuss in the next lecture. Okay, I will upload that video, you can follow that video also. Now on the basis of on the basis of rigidity, if we want to design the shaft, the second criteria is on the basis of rigidity. Then if we say that we want to design the shaft on the basis of the rigidity, then we want to say that the deflection of the shaft due to the given loading condition, that is because of this loading condition that is acting on the shaft, you can see this, there must be some deflection in the shaft, but that is the material of the shaft will deform, and that deformation must be smaller than the permissible value of deformation or limiting value of deformation in the shaft. Okay, so the deformation must be smaller than permissible value of deformation or limiting value of the deformation for the shaft material. So then we can say that the shaft is designed on the basis of strength. Now in this video we will discuss the design on the basis of the strength, and in the next video we will see the design on the basis of rigidity. Now see this, friends, uh, when we want to design the shaft on the basis of the strength, then the first step is always to find out the material of the shaft. Now the shaft are generally made of plain carbon steel and alloy steel, we all know that. So you have to choose a material according to the application for which you want to design the shaft. Now the next step is we have to calculate the permissible value of stress, that is the limiting value of the stress for the shaft material. That is the limiting value of the stress that the shaft material can withstand. Okay, now because the shaft are made of ductile material, so permissible value of stress is taken as the yield strength in shear of the material. Now because shaft are made of ductile material, so the permissible value of stress or limiting value of stress is generally taken as shear stress, shear strength of the material of the shaft. And according to the uh, maximum shear stress theory, we know that the shear stress, a permissible shear stress in the shaft material is equal to the ultimate tensile strength for the shaft material divided by 2, which can be given using this formula. You can see this for ductile materials. Okay, so permissible value of stress for the material of the shaft or limiting value of the stress can be find out using this formula. We know the value of yield strength in tension, which can be obtained from the design data book according to the material of the shaft, and we divide when we divide this yield strength in the of the material of the shaft by 2, then we will get the permissible shear stress for the shaft material. Okay. Now friends, we have to find out the maximum value of the stress, okay, that is produced in the shaft material because of the loading condition. That is the given loading, because of the given loading condition, we have to find out the stress produced in the shaft, the maximum value of the stress. Suppose this is the loading condition as shown here, and the turning movement is acting on the shaft, that is the twisting movement is acting, and the bending movement MB is acting on this shaft. Now because of this twisting movement and bending movement, there must be a shear stress which has to be induced in the shaft because of this loading condition. So that maximum shear stress can be given using the maximum shear stress theory using this formula. Okay, here in this formula you can see that tau max is equal to 16 by pi d cube mb square plus mt square. Here mb is the bending moment and mt is the twisting moment acting on the shaft. So shear stress induced in the shaft, maximum shear induced in the shaft because of this loading condition is given by this formula. So we have got the value of the maximum shear stress induced in the shaft. Now to design the shaft, what we have to do, we have to equate this maximum shear stress induced in the shaft because of this loading condition which is given by this formula to the permissible value of shear stress that we have obtained in the step number 2. So when we equate the tau max, that is the maximum value of shear stress induced in the shaft because of the loading condition, to the permissible value of the stress obtained in the step number 2, then we can easily get the diameter of the shaft. Okay, now here you can see that uh, for safe design, the permissible value of the shear stress according to the maximum shear stress theory must be greater than the maximum shear stress induced due to the given loading condition in the shaft. So this relation must hold for safe design. And to find out the diameter, we have to equate tau permissible with tau max, that is permissible value of stress is equal to maximum value of stress induced in the component because of the loading condition. We have to equate these two things. Okay, tau permissible obtained in the step 2 is equated with the tau max obtained in the step number 3. So when you equate this, then you can see that this S by D is the yield strength and tension for the material of the shaft. You can see in this in the formula. You can obtain the value of the yield strength and tension denoted by S by T here from the design data book, and the MB can be obtained from the question because this is the bending moment acting on the shaft and MT is the twisting moment acting on the shaft, and here diameter is the only unknown thing. Now if we incorporate the factor of the safety in here in the design, then you can divide the yield strength and tension by factor of safety also. That is the permissible value of stress can be obtained by dividing it with the factor of the safety. Then you have here I have incorporated the factor of the safety, and when you equate it with the tau max, that is 16 by pi d cube under root mb square plus mt square, then everything is known here in this formula, but diameter is unknown, so diameter can be calculated using this relation. So this was all for today's topic, and if you like my video, you can subscribe my channel and also press the bell icon for the notification of the upcoming video. Thank you friend.